everyone, this is Mrs. Jackson, and this is part 2 of Chapter 1, Section 4 on arithmetic sequence formulas. So in the last video, we kind of broke down an arithmetic sequence of numbers, and we, through that process, developed a formula for the nth term, or the nth number in the sequence. And that particular formula is called an explicit formula. So we'll also reinforce that in this video. And I'm going to introduce a different type of formula called a recursive formula. And then finally, we're going to compare two different notation styles for sequences. The first one we already looked at and we've been using is function notation. But I'm also going to show you what subscript notation looks like because that is very common in textbooks. Okay, so let's get started. I have an example here. I've got a list of numbers in a sequence. So the first thing we would always do is kind of make a table. So I'm going to say n, and I'm going to say f of n, since function notation is what we've been using. So our first number is 11, our second number is 8, our third number is 5, our fourth number is 2, our fifth number is -1, and our sixth number is -4, ... going out to n, and ... going out to f of n. And we can see a pattern here that we are going down by 3 consistently. So that's the sign of an arithmetic sequence. Okay, the first thing is a recursive formula. So unlike the formula we looked at in the previous video, recursive formula you use to find the next term, but you need to know the previous term in order to do it. And then you just keep the pattern going. For example, if I wanted to know f of 7 here, I would take f of 6, which is -4, and I would subtract 3 from it. So it's somewhat limited in its use, and I'm not going to be focusing too much on the recursive formula because it is limited. But let's just make a note here that the recursive formula, you need the number before. So you need the previous term, let's say, in order to get the next one. That's what makes it somewhat limited, because if you wanted to find f of 100, you would need to go all the way out to f of 99. Okay, but what it looks like here, just to put it in function notation, is whatever term we want, f of n, you're going to use the previous term to get it. And the way we would write the previous term in notation is n minus 1, f of n minus 1. So for example, if I wanted f of 50, then I would use f of 49, and that is n50 minus 1. And then you're just going to add your common difference, whatever that pattern is. And so in this particular example above, we have f of n, our recursive, equals f of n minus 1. And our d here is a negative, so we're going to subtract the 3. And that's our explicit formula. So if we wanted to use that, for example, to find f of 7, let me just write example here. F of 7 is going to equal f of 7 minus 1 minus 3. So f of 7 is going to equal f of 6 minus 3. Our f of 6 is -4. So I'm going to substitute that in, and I can find f of 7 to be -7. Okay, let's compare what subscript notation looks like for this example compared to function notation. So subscript notation uses subscripts, and generally they use a subscript n. So that would be your output at the nth position. And recursively then, that would mean take the output in the previous position and then your common difference, add your common difference. So in this example, we would have a sub n equals a sub n minus 1, that's how you would read that, minus 3. And then if we looked at another example here, say a sub 7, we'll do exactly what we did to the left. A sub 7 would be a sub 7 minus 1, or a sub 6 minus 3. And so we would just take our same numbers that we did previously. -4, whoops. -4 minus 3 equals -7. So in this style of notation, which is pretty common in textbooks as well as online, sequences and series would use this type of notation. All right, but as I said, I find the recursive formula to be very limited in its use, so I'm not really going to focus that on any type of tests or quizzes, but I will focus more on the explicit formula, which we developed in the last video. The explicit formula says that our output is going to equal the very first number in the sequence plus our common difference times n minus 1. So that's the explicit formula in function notation. So this is far more useful. So maybe we do an example here. Find the 100th number in the sequence of 100. We're going to start out with our first number in our sequence. Because our common difference is negative, I'll represent that as subtraction. So this would be 100 minus 1. F of 100 equals our first number in our sequence is 11. And of course I have to do this multiplication over here before that subtraction. F of 100 equals 11. I'm going to think of 99 as 90 plus 9. That way I could do the math in my head. So 3 times 90 would be -270. And 3 times 9 is -27. So I've got 11 minus 297. So that's going to give me -286. So that is the 100th number in this particular sequence. All right, how does this look in subscript notation? We've got a sub n equals a sub 1, the first number in the sequence, plus d times n minus 1. So if we wanted to do some kind of example, let's do a different example. Let's do a sub 50. So if I want to define a sub 50, that's the 50th number in the sequence. I'm going to take the first number in my sequence, and in our particular example, I'll use -3 and 50 minus 1. So a sub 50 is going to equal 11 minus 3 times 49. Again, I'm going to think of that as distributive property. 3 times 40 is 120 minus 27. I've got 11 minus 147, and that's going to give me -136. So the 50th number in this sequence is -136, and that's an example of how we would write both function notation and subscript notation. In any kind of test or quiz coming up, I'm going to focus only on the explicit formula because I think that's the one that's most useful. Okay, I hope this video helps.